Electrical safety. On average, there's one worker in the United States electrocuted on the job every day. There are four main types of electrical injuries: electrocution, electrical shock, burns, and falls. Let's talk a little bit about electrical terminology. Current is the movement of electrical charge. Resistance is the opposition to current flow. Voltage is a measure of electrical force. Conductors, these are substances such as metals that have little resistance to electricity. You have insulators such as wood, rubber, and glass, which have a high resistance to electricity. And then you have grounding. This is a conductive connection to the earth, which acts as a protective measure. Electrical shock. Electrical shock is received when current passes through the body. The severity depends on the path, the amount of current, and the length of time. And remember, low voltage does not mean low hazard. Currents greater than 75 milliamps can cause ventricular fibrillation. This is the rapid ineffective heartbeat. It's what happens when you have a heart attack. The heart doesn't fully constrict and beat. It just kind of flutters. 75 milliamps, not much current. A small power drill uses about 30 times this much. Electrical shock, how does it happen? When two wires have a different potential difference or voltage, current's going to flow as if they're connected. In most households, black wire will be 110 volts relative to ground, and the white wire is going to have 0. When you come in contact with a black wire, an energized wire, and you also come in contact with a white or a grounded wire, current's going to pass through your body, and you're going to get shocked. If you're in contact with an energized wire, and you come in contact with something that's grounded, a grounded object such as a gas pipe, water pipe, you're going to get shocked. And if you come in contact with both wires of a 240 volt cable, you're going to receive a bad shock, possibly be electrocuted. The most common injury with humans involving electricity are burns. The body is not a great conductor of electricity, a lot of resistance. When you try to pass electricity through it, that resistance turns into heat, and it will burn you. Another more common accident that happens is somebody's working on something electrical in nature. They're elevated on a ladder, and they get shocked, and when they jerk away from it, they fall off the ladder, resulting in very serious injuries, sometimes fatalities. Inadequate wiring is a serious problem. A hazard exists when the wire you're trying to use is too small for the amount of current. In a household wiring system, you have a breaker which is set up to carry so many amps, and the wires are designed to carry more amps than the breaker, so that if you plug in something, the circuit breaker will trip or the fuse will blow before the wire gets too hot to melt. This is what prevents us from burning homes down. But if you're using a portable tool and you have an extension cord that has a small wire on it, or the wires are smaller than the circuit's designed for, the tool can draw more current than the cord can handle, causing overheating and possibly a fire without tripping the circuit breaker. The circuit breaker could be the right size, but because you've introduced a wire into that circuit that is undersized for the circuit, the breaker cannot do its job. Overloading circuits is a serious problem. Don't plug in too many devices into one outlet. There are a lot of electrical protective devices engineered into our systems to help prevent us from being shocked and for preventing fires. Fuses, circuit breakers, ground fault circuit interrupters all shut off the electrical flow in the event of an overload or a ground fault in the circuit. While fuses melt and circuit breakers trip when there's too much current, the GFCI, ground fault circuit interrupter, will trip if it senses a difference in the voltage leaving the outlet and the voltage coming back. If 120 volts goes out the black wire and goes through your device, 120 volts should be coming back through the white wire. If it senses a difference here, it will trip the circuit. It's doing that because it knows that the voltage is going somewhere that it should not be, possibly into your body. This happens very quickly in as little as 1/40th of a second. Grounding hazards are the most common reason for OSHA citations. Metal parts of an electrical wiring system that we touch, things like switch plates, ceiling fans, stuff like that, should always have 0 volts relative to ground. If you touch something that you should be able to touch, like an appliance or something like that, and you feel a tingle, you have a problem. Housings on motors, appliances, things like that should all be 0 volts to ground, and you should not feel any kind of little sensation, tingling sensations. If you do, something is not grounded properly. Overhead power lines. Overhead power lines present a very significant and serious hazard. Overhead power lines are usually not insulated. You never want to use a metal or aluminum ladder around overhead power lines. Only use fiberglass ladders working around outside overhead power lines. You must stay at least 10 feet away from overhead power lines. Remember, electricity is trying to find its easiest path to ground. If you approach an overhead power line and become closer than 10 feet, it is possible for that power to jump from the line to you, and then you become part of the circuit to ground. And there are a lot of fatalities caused by people just approaching too close. It is an OSHA violation to get any closer than 10 feet from an overhead power line. And this includes anything that you're working on. So if you were holding a large metal object or something that was 3 feet long, and that object in your hand would have to be 10 feet away from the power lines. This is a very serious, critical thing that everybody must be aware of. Anytime you're carrying ladders outside, especially in the elevated position, you must be aware of where the overhead power lines are. Take time to find them before you start moving and doing any kind of outside work. Here's some examples of some OSHA violations. Here's a ground plug where somebody needed to plug this in. They didn't have a 3-prong outlet, and so they cut off the ground. This is unacceptable. If you have an appliance that has a 3-prong cord, you must plug it into a 3-prong outlet. Older homes only have 2-prong outlets if they've not been rewired up to code. And there are a lot of extension cords made for lower voltage things like Christmas tree lights that only have 2-prong outlets. You may not use a 3-prong plug in an extension cord designed for 2 prongs. This is a serious OSHA violation and a serious hazard. Handheld electrical tools are at serious danger because your hands are in contact with them, and you're most probably standing on ground when you're doing it. There's certain things that must take place here. You must have 3-wire cord or ground, to plug it into. It must be double insulated, and it should be powered by a low voltage isolation transformer. Anytime you're outside or working around water, you should always be using a ground fault circuit interrupter in your circuit to protect you from a handheld electrical shock. Live parts must be guarded. Equipment, you must guard live parts of anything more than 50 volts. Okay, it must be in either an approved cabinet or enclosure, or located with permanent partitions to prevent somebody that is not qualified from gaining access, or it must be elevated 8 feet or more above the ground. And or entrances should be marked with signs stating high voltage. It's very important that your electrical parts are protected from physical damage. You must enclose or guard them so that it's not possible for somebody to drive a fork truck by or bump into it and break it off. What you have here is an example of an electrical piece of conduit that got knocked off of the cabinet. Now you have exposed wires coming out, and over time these wires are going to become abraded, possibly causing a short in the circuit, a fire, or an electrical shock to somebody. It's very common to see OSHA violations for junction boxes that have missing knockouts or cover plates. Somebody's made a repair, pulled some new wire, they were lazy, they didn't put the cover plate back on, or they lost it, left it. This is unacceptable. This will get you an OSHA violation right here. Flexible cords is another area where we see a lot of OSHA violations. That's one of the first things an inspector will look at as he walks through your facility or your job site. Cords are going to age over time. People run them through doors, slam doors and windows on them, damaging them. I've seen people staple them to the walls to get them out of the way so people wouldn't trip on them. And you can get abrasion just from dragging them over, concrete steps and things like that over time. If you have damaged cords, get rid of them. There is no safe way to repair them, and there's no acceptable OSHA repair for an extension cord. If it's damaged, get rid of it. It's going to get you a citation or possibly an injury. Clues that you have an electrical hazard. If you have a tripped circuit breaker or blown fuses, you have a problem. If your tool is heating up warm or the wires are getting hot, when you're using an appliance or a tool, you have a problem. If the GFCI trips the circuit, that electricity is going somewhere, possibly into your body, you have a problem. If you have worn or frayed connections on wires, you have a problem. Very important for employees to receive training on equipment and safe work practices. There's going to be another module that you will view regarding lockout tagout, which will go into detail about de-energizing electrical equipment before you do any inspection or repairs. You must use electrical tools that are in good repair. You must use good judgment when working near energized power lines. This is a serious hazard. And you must use appropriate protective equipment if you are a qualified electrician anytime you are working on live energized parts, especially anything that could present the hazard of an arc blast. In summary, there are a lot of hazards that you need to be aware of and take action if you're presented with. Inadequate wiring, exposed electrical parts, wires with bad insulation, ungrounded electrical systems and tools, overloaded circuits, damaged power tools and equipment, using the wrong PPE or tools if you are a qualified electrician. Overhead power lines presents a very serious hazard that I cannot overemphasize. And of course, all these hazards are made worse if you're working in wet conditions. There are protective measures that you've been made aware of during this training. Proper grounding is critical. Always using ground fault circuit interrupters anytime you're working with hand tools, especially around water or outside. Using fuses and circuit breakers are our engineered solutions to prevent fires and electrical shock. Guarding of live parts. Anytime you have exposed wires, you have a problem, you need to report it and have a qualified person fix it. Proper use of flexible electrical cords. Anytime you have extension cords, make sure that they are in good repair. Inspect them and dispose of them if they are damaged. And of course, training. I want to thank you. If you have any questions regarding electrical safety, please see your supervisor. He will answer them.